paleontologists are starting to explore radically new clues from dinosaur skeletons. Christy Curry Rogers cuts into their bones to examine the pattern of what was once living tissue.
And is it sort of like CSI for dinosaurs?
It can be, sure. Sometimes it's kind of a different method of detective work. We can see in these cross-sections of bones evidence of pathology, evidence of dinosaur disease, and evidence of dinosaur bones breaking and healing themselves. All of that stuff is available via the inside look at a dinosaur bone.
Analyzing the rock that entombed dinosaur fossils is key to understanding how they were preserved, which is the work of Christie's husband, geologist Ray Rogers.
And I'm there to try to place the discoveries in context, to try to find clues as to where maybe best to look for fossils. We've been pretty lucky in Madagascar. This is typical of the Madagascar material. It is not heavily stained. It's not been invested with iron, with manganese. It doesn't look like a typical fossil. If you didn't know, you might think you're picking up a cow bone today, a bleached cow bone.
I think this piece might be good, or maybe...
The Madagascar bones are so perfectly preserved that Ray and Christie wondered if they might conceal clues about how these dinosaurs lived. To find out, they turned to their colleague, Mary Schweitzer, a paleobiologist whose study of ancient cells and tissues might solve the mystery.
We know that dinosaurs had to have cells, bone cells and muscle cells and gut cells and brain cells. And that's one of the reasons we can study them, even though they're extinct. I was working on the leg bones, and as I worked, I noticed a bunch of stuff. It was like, you know, this bone, there is hollow inside. And I was looking at this thing, thinking, this is really interesting.
It was the inside of the T-Rex bone that fascinated Schweitzer, who made thin sections out of it. And in these cross-sections of fossilized bone, she saw something that she and everyone else had thought was impossible. Round structures that looked like red blood cells, dinosaur blood cells.
Inside those channels where the blood vessels would have run were these little round red structures that were all kind of lined up like a train, and they were bright red and translucent. Nobody else had seen anything like that before.
The very idea of blood cells in a 70-million-year-old bone was more than unconventional. It was radical.
Nobody was imagining that dinosaurs might have had preserved soft tissues.
Derek Briggs is curator of invertebrate paleontology at the Peabody Museum at Yale University.
So along comes Mary Schweitzer, and she's starting to look inside dinosaur bones and has made this startling discovery about the presence of red blood cells. What was your initial reaction to that?
Oh, I think the same reaction as everybody's, that this was totally improbable. She'd perhaps misinterpreted the evidence or was exaggerating the potential for what she was seeing.
So skeptical at first?
Oh yeah, definitely.
Paleontology has been around for some time.
One of the oldest professions.
One of the oldest professions. Has anybody else that you know of found similar things inside a bone?
No.
Why do you think it didn't occur to anybody?
Because we have this clear understanding that part of all biological cycles involves decay. I mean, nature is set up to break down that material and recycle it. So it's just improbable that those kinds of very delicate structures would survive, particularly for millions of years.
When you think about it, the laws of chemistry, biology, and everything else that we know say that it should be gone. It should be degraded completely.
But Schweitzer kept searching for organic remains where no one had thought to look before. Her mentor is Jack Horner, one of the most famous dinosaur hunters in the world. When his team found another beautifully preserved T-Rex in the remote Montana Badlands, the massive leg bone had to be broken in half for transport, and Schweitzer got to test fragments from deep inside the bone.
The T-Rex bone was filled with a very unique bone tissue. When I turned it, like that, and looked down on it and saw this tissue that you can see right there in cross-section, I knew what it was.
It's called medullary tissue, and it's what female birds build up inside their bones as a source of calcium for the eggs they lay. All dinosaurs laid eggs, and it made sense to Schweitzer that female dinosaurs produced the same kind of bone tissue. It looks different from the surrounding bone, and it meant the T-Rex had to be a mother, expecting a clutch of dinosaur eggs.
It was really exciting for me. I thought there's nothing in my career that could possibly be cooler than being able to identify the first pregnant T-Rex.
No one had ever identified medullary tissue in a dinosaur bone before. But to be sure, Mary Schweitzer directed her lab assistant to soak the bone sample in an acid solution to reveal its structure so she could study it. What happened next would change the way that scientists thought about fossils forever.
As I was looking in the microscope, the medullary material was no longer hard, and what was left was this curled piece of tissue that I was using forceps to try and flatten out. And when I poked into it, it was spongy. It was flexible and soft tissue.
Flexible tissue from a 68-million-year-old dinosaur?
Blood vessels.
There they are.
Transparent, hollow, pliable, flexible, branching blood vessels that contain small, round, red microstructures floating in the vessels. I said, this is not possible. Do it again. We got another piece of bone. We put it in the solution. We waited 2 or 3 or 4 weeks. Looked again. More blood vessels. We must have repeated that with probably 17 or 18 different fragments of bone.
As soon as Schweitzer's discovery of dinosaur soft tissue was published, people thought of one thing. Could we get a real-life Jurassic Park? No paleontologist believes we could ever get enough ancient DNA to clone a dinosaur, but could fragments of genetic material be extracted from this new tissue?
I think anything is possible. If there are blood vessels and red blood cells preserved in the dinosaur, I think it's quite possible that there will be DNA there as well.
Even without DNA, proteins from soft tissue could begin to answer real mysteries about dinosaur biology. Evidence of warm blood versus cold blood, whether the large body size of dinosaurs is linked to large cell size. The Rogers have a theory that dinosaur mass deaths in Madagascar might have been caused by water poisoned by algae. This poisoning event wouldn't show up in hard bone, but they might be able to test the theory with dinosaur blood cells.
The structure, I mean, there's a lot of structure there. If there's anything in this tissue that Mary finds that actually can trace a toxin, that would be fantastic. Things like disease, diets, things like that from soft tissue that you can't extract from hard tissue, from true fossil bone.
The hope is that the Madagascar fossils will allow Mary to find more dinosaur tissue. So, Ray and Christy gather fragments of their best preserved fossils. A few days later, the samples arrive at Schweitzer's lab at North Carolina State University. She uses the same technique that yielded soft tissue in the T-Rex bone, soaking the fragments in a mild acid that dissolves away the mineral part of the bone. But will she be able to find the same internal structures in Ray and Christy's fossils?
There's only so much you can know from looking at the outsides of bones, but when there's soft stuff inside, the possibilities become almost endless. This is a single cell.
Through photos from her microscope, the jackpot, pieces of biological history.
Now see, this is really cool. It's what looks like vessels to me, connected together, transparent. And you can see right there, you can see the branch points and stuff.
The Rogers are seeing inside their collection of fossil bone as they've never seen it before. Structures that appear to be the vessels that once carried blood inside a dinosaur's body.
This is hooked together. There's a transparent region.
It's a tube with stuff inside of it.
Branching, hollow, organic material that scientists thought could never be preserved in a dinosaur fossil.
That's amazing. But this is from 65, 70 million year old bone.
It's too early for these structures to reveal details like dinosaurs dying from poisoned water. But dinosaur soft tissue opens a door that no scientist thought even existed until Schweitzer's work changed that assumption.
There's little doubt in my mind that what she has discovered are internal structures in dinosaur bone. And we may look back and say, well, this sort of approach to looking at fossil vertebrate biology has revolutionized the field.